When we did Project Zero, we chose some parts out of the Multisim database, and there's a lot of parts in there. But ultimately, you're going to design something new, and you're going to use some newfangled part from your favorite manufacturer, and Multisim is not going to have a component of this new part. So in this lesson, we're going to go over what the databases are and how to create a new schematic symbol and a new footprint and combine them into a component and put that into your databases. So let's get started. It's a component in Multisim. It pops open a select component window, and you have the option to pick a component from one of three places. There's the master database, the corporate database, and the user database. Now the master database is a library of components that comes from National Instruments, ready-made for you, and it ranges from really basic parts like a resistor that you've got to pick the footprint to a very specific component that comes from a specific manufacturer. So for example, if I go into the master database here and I pick in the power section a voltage regulator, there's a 2594 component, which is a simple switcher, and that's the simple switcher that we used in the Arduino board. That's the power supply section. So that's where I got that component. I didn't have to make that one. The next level of databases is the corporate database. And the corporate databases is a company database that as engineers build up a library of their own good parts within the company, they'll release them to the corporate database, which gets saved on the network. Every engineer is supposed to pick their components for a design from the corporate database first. These are parts that have been checked out and they're known good. The footprint works, manufacturing likes to solder it. We have them in stock. You should pick from there first. So a company will build up thousands of their own parts. But now you're an engineer sitting on your desk, you've found this fancy whiz-bang part that you want to use, and it's not in the corporate database. Well, what do? So what you want to do is you want to create the component on your machine, and you want to put it into the user database. So the user database now is a component saved on your local hard drive. And when it gets checked and accepted, it'll get released into the corporate database so that other engineers can use it. So the user database is a set of your own parts that you've been making up, and these are new things. So let's go through the process of making a new component and putting it into your user database. Now the one I like to start with and give students is this automotive H-bridge driver from STI, and it's a VNH3SP30. And the reason I like to give this one out is that it's reasonably challenging enough. It has an interesting footprint that you have to make an interesting schematic symbol. So from the top side, the VNH looks like a 30-pin package, kind of like an SOIC with its legs spread out sideways. But what makes it interesting is that on the bottom of it, so there's the top view, but on the bottom view, it has these three big pads in the middle. So you've got to make those pads. So it's not a totally symmetric part. You've got 15 on either side that's symmetric, but then you got one big one on one side and two big ones on the other side, and they're underneath. So that's kind of interesting. And the other thing that's interesting about it is that it has a schematic symbol that has fewer parts than pins on the footprint. And this is one of the things to remember about schematic and footprint is when you make the schematic symbol, you're looking at it from a functional view, which is a block diagram view. So a schematic symbol for most ICs is just a square with pins on the side. And it doesn't have to be one-to-one. For instance, on this schematic here, I see 1, 2, 3, 4, 5, 6, 7, 8, 9. I see 10 pins coming out of the schematic. But if you remember, there were 30 pins on the outside of this chip and 3 underneath. So the footprint has 33 pads and the schematic only has 10 connections. So they're an unequal number. And if you take a look at this part a little further on this page here, you can see that a lot of the pins from the schematic go to multiple pins on the footprint. So for instance, these guys over here, there's 3 ground pins in a row. They all go to the same connection on the circuit board, but the ground A is only shown as 1 pin in the schematic symbol. And then the out A here, this out A, well, that's connected to this thing on the bottom, which is also connected to this pin on the opposite side. So there's a lot of things that are interconnected. The schematic has only 10 pins, but some of those pins are connected to 2, 3, 4 pins on the footprint. So it's a good one to do for your first time. So I've been using the terminology of a component and a schematic symbol and a footprint a little loosely. So let's get that tied down. So a schematic symbol is how you see the part when you're working on the schematic in Multisim. And it's a functional block diagram that tells you how to connect it. The footprint is the view that you see when you're in Ultiboard and you're trying to route your circuit board traces. Now a component is kind of like a top level, and it's a list of associated information about a part. You can have a component can have a schematic symbol, a component can have a footprint, and a component can also have places where you can buy it listed and what the pricing is, and that's information that would be used by purchasing. So our job, if we're going to create the component, is our job is to do the schematic symbol and the footprint. Now what happens when you go to do the schematic symbol is one of the first questions it asks you is, what footprint would you like to use? Which usually ends up being a little bit of a roadblock. So I usually like to make the footprint first in Ultiboard. Then when I go to make the schematic, it's there available for me to select. So let's go into Ultiboard. So we can use the part wizard to create a basic part that has the important characteristics of what we want. And the part wizard will lead you through a series of questions, so you just pick things. We want a surface mount part. We want what kind of basic footprint, not 4 on each side. We want a gull wing thing that has part pins on both sides. What's the dimension of the component package? So we should go into millimeters here, and then we refer to the data sheet, and the part is E1 high and D wide, and on the data sheet it says that that is 17.2 by 16. So we come back here and we punch that in, 17.2 by 16, and that gets us the basic pin position, or sorry, that gets us the basic overall size of the component package. And then there's 3D height information here that you can type in, and that makes it look good when you rotate it. Then there's color, 3D color for rotation and light coming in. And now we're on to the actual pads, the size of the pad, and whether or not it's custom pad. And you can set a circular pad or a rectangular pad. So we'll just leave it at 0.6 by 2.2. Then how many pads? There's 30 around the outside. And the distance between the pins, but we'll just leave it for now. How do the pins count? Counterclockwise. And then it drops down a basic component for you, and now you can fine tune it. I made a mistake when I put the pin distance here, but I can always come in here and I can move things around like so. I can grab a group and move them around when you have the select enables correctly. I can also grab a bunch of parts here, and I can bring up the XY location, so I can say that the Y is minus 200. And I can move it into place this way. So minus 400, we'll go to 400. So you can grab them and move them, or you can punch in the location, and the location will be referenced to the center of the pin. And now you've got these pads on the bottom. And what you would do with those is you would place a pin, and you can just place a through hole or a surface mount pin, and then you can decide what shape of pin you want. So let's put in a rectangular pin, and you can put down physical pins. And once the first one's down, you can cut and paste the other ones. And then you can bring up the properties, and you can type in the X and Y location. So there, I moved it. And you can also type in the actual size. Length of 200, width of 100. Apply. Now the information for that, you need to extract from this diagram, and it's not going to be referenced to the same points that it is in Ultiboard. So they give you the width between these two guys and the width between these two guys. But Ultiboard wants everything centered from here. So you got to do a little bit of math to convert this correctly and get the pins in the right spot. So once you've got your pads down, what you can do is you can save this to the database as. So you can save it to the database as, and you can save that, give it a name, and you can then save that to the database, and that is your new footprint. So now we're going to go back to Multisim, and we're going to create a component, which is a schematic symbol, and bring in the footprint. And there's a wizard for that as well. So we come up to the tools, there's a component wizard, and again a series of questions. So this is going to be my H-bridge driver. One of the questions here says simulation and layout, simulation only or layout only. In order to do simulation, you have to find the piece-by-piece model at the manufacturer's site, and those are hard to find. So I would say we're going to do this for layout only. We won't be able to simulate the part in Multisim. The package type, now we can select a package, and this is where you go through your footprint database and you pick out the footprint that you made for this part. So I'll pick this one. And now we enter the number of pins. And this is the number of pins on the schematic, not on the footprint. And the number of pins, we counted those before. I think it was 10. So we'll put in 10 pins in the schematic view. And then it drops down a whatever pin device you asked for, and it puts them on all sides even. Let's edit that to make it look more like what we want it to look like. So that brings up the symbol editor, and now I can modify the symbol. And usually the first thing I want to do is resize the boundary box. So the boundary box is the outline for the schematic symbol. This box here that we have in the middle, that's just a rectangle. That's just a graphic object. So don't think that defines the boundary of your part. That's defined by the boundary box. So here we can stretch this so that it goes right to the outside. There's 10 pins. You can start moving these pins around. You can start naming these pins. So there's out A. There's out B. There's VCC. There's ground. You can go around and you can assign sensical names to these pins so that it looks properly on the schematic. It's an H-bridge driver, which usually has something like power and ground on one side. So usually we'd end up with VCC and ground on one side. And then the output to the motor driver, if it's a motor driver, you would have the outputs to that. So you hook this to power, hook this to ground, and then here's the hook to your motor. And then over here, usually in a schematic, you put inputs on the left-hand side, outputs on the right-hand side, and so the schematic would look something like that. Now we need to save this. And then we can close it. If you don't save it, it loses it. And then we'll close it. And then you can go, now you can see it appeared here. Then it goes next. And we can skip the pin table. And now we get to this point here. It says we need to map the pins. So what you need to do is over here, out A, you need to refer back to your data sheet and figure out which pins out A goes to. So it goes to 1, it goes to 30, and it goes to the heat slug underneath. So on the package, it goes to 1, it goes to 30, and then the slug on the bottom was 33. And we say, go down to the next one, and you set that. So basically now you connect your schematic symbol pins to your footprint pins. And there may be a 1:3 ratio. It's not necessarily 1:1. That's what I talked about at the beginning here, is that one thing on your schematic may connect to more than one pin on the output. So then you go next, and then you save it to your database, and this is the user database. You pick a group, and I would probably put something like this in the powers. And in fact, here I've got something that says driver, and I can put it in there, and then I've got a component. So here's the schematic symbol. Doesn't look like the pin names are visible. So let's show package pin names, show symbol pin names, and then the pin names come up on it. And if I forward annotate, save the net list, it brings it in and drops my new part down here in the corner. So there you go. I've created a schematic symbol, and I've created a footprint, and I've saved them in my user database as a component. And now probably you'd want to go through and check that everything lines up, that this thing here has the same name as it does on the schematic symbol. So sometimes I'll put down a piece of wire, and then I'll grab this net, and I'll name that net VCC. And I'll put like a little piece of wire for everything around here. Actually, it was out A. We'll do this one here. So we'll call that one out B. Call this one out A. So I've put a little bit of wire on them that doesn't go anywhere, but I've given the wire a name. So when I forward annotate this, it says, bring the changes over, okay. Now here in Ultiboard, you can see that pin 30 is connected to out A. So usually after I've made a schematic symbol and a footprint, I'll plunk down a bunch of wires and I'll forward annotate it, and then I'll make sure that everything here that gets named matches what it says here on the data sheet. So that's one of the checks I'll do to make sure it's correct. So that's how you make a component. And as your exercise, I'm going to get you to make this component because it's got lots of pins and some interesting pins, and I think it's a good component to make.